A histogram looks like a bar graph, but it represents the frequency that something occurs. So let's say we have students in a class, and they took a test, and the scores ranged from 75 to 100. There were 75s, 82s, 93s, and 97s, 100s. And this represents the grades or the scores. And the side, the y-axis, represents the frequency. The amount of times this grade occurred, or the amount of students that got this grade. If the test was a fair test, then the graph is going to look something like this. We're going to have a few people getting 75s. We're going to have a few more people getting 82s. And then a lot of people getting 93s. Some people getting 97s. And some people getting 100s. But the data is normally distributed because it looks like a normal bell curve. There are a few people getting on the lower end, then a lot of people getting in the middle, and a few people getting on the higher end. That is a normally distributed graph. Let's say we have students in a class that took a test, and the grades are over here. The frequency or the number of students that got those grades are over here. And we'll do the same score, 75, 82, 93, 97, and 100. And we had a lot of students getting 75s, a lot of students getting 82s, fewer students getting 93s, fewer students getting 97s, and even fewer students getting 100. This graph is not normally distributed because we have a lot of students getting on the lower end and very few students getting on the higher end. This is what we call a skewed graph, and this graph is said to be skewed right because we have fewer values on the right. We could also have a graph that's skewed left. Let's use the same scenario. We have students taking a test and they got grades on their test, and we'll use 75, 82, 93, 97, 100. This is going to be the frequency. And we had very few students getting 75s, few students getting 82s, more students getting 93s, even more students getting 97s, and a lot of students getting 100. This graph is not normally distributed because we have many more values on the higher end. This graph is said to be skewed left because we have fewer values on the left-hand side. Another way we could represent this data if we didn't want to use a histogram is by using a dot plot. A dot plot is the same thing, really. We have grades and we have the frequency or the amount of times that each of these grades occur. Let's use the same thing, 75, 82, 93, 97, 100. Instead of making bars, we're going to make dots. So each of these dots represents a student. So it represents how many times this grade occurred. So we have 3 75s, 4 82s, 6 93s, 4 97s, and 300s. This graph is normally distributed because we have it goes up, 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 up towards the middle, and it goes down, down, down. We could have a skewed dot plot also. These are the grades, frequency, 75, 82, 93, 97, 100. We could have a lot of students, 1, 2, 3, 4, 5, 6, 7 students getting 75s, 6 students getting 82s, 4 students getting 93s, 2 students getting 97s, and only 1 student getting 100. This graph is skewed. This graph is skewed right because we have fewer values on the right. We have a lot of values on the left and very few values on the right. We could have the dot plot that's skewed left. 75, 82, 93, 97, 100. We could have 2 75s, 4 82s, 5 93s, 7 97s, and 10 hundreds. This graph is skewed left because we have much fewer values on the left and a lot of values on the right. Let's say you have a set of data. Let's say we have ages of students in a cafeteria. we have 7, 6, 7, 8, 8, 8, 9, 10, 9, 8. We have all these data points, and we want to know, is it normally distributed, is it skewed left, or is it skewed right? So we can have the calculator draw for us a histogram. It won't draw for us a dot plot, but it'll draw for us a histogram showing the data, and we'll be able to see, is it normally distributed like the first graph, is it skewed right like the second graph, or is it skewed left like the third graph? We're going to press the Stat button, Edit, and we're going to enter all of our data points into L1 into List 1. Then we're going to press second, Y equals, so we're in the Stat Plot menu. We're going to use Plot 1, so we're going to press Enter. We're going to highlight the On button, press Enter to highlight it. We're going to scroll down to Type, and we're going to the right arrow until we highlight the histogram picture and press Enter. Our X list, the list of our values, is in L1, so that's correct. Our frequency we leave as 1. Color, doesn't matter, we could do blue. Then we're going to press the Zoom button, and we're going to do Zoom 9 for Zoom Stat, Zoom Statistics. And the calculator drew for us the histogram of what these data points look like. And notice that it looks normally distributed. We have a few values on the left, a few values on the right, and a lot of values in the middle. So this graph is normally distributed. Using the calculator is an easy way to determine whether a graph is normally distributed, skewed right, or skewed left.